So in this video looking at surds, we'll be focusing on how to add, subtract, multiply and divide numbers involving surds. Now there are certain rules of surds that we must acknowledge before performing any calculations involving a square root or surds. Now the first one is that when we are adding surds together, that they cannot join together. So for example, if I kind of put some of these algebraic sort of rules in terms of numbers, so for this first one, if I had root 2 plus root 3, then that is not going to equal root 5 where I've added the numbers up. And the same thing applies if I'm taking away. So for example, if I was taking away, so it'd be root 2 minus root 3, then that would definitely not equal minus 1. So, because obviously it's one, we don't subtract in this sort of way, but also you can't end up with a negative number inside a square root. Now the next one is when we have got numbers outside and the surds are the same, then yes, we can join them up. So for example, if I had 2 root 3 plus 5 root 3, then the numbers outside can be added or subtracted together. So that would be 2 plus 5, which is 7 root 3. And there would be my final answer. Now the key thing to note is that we don't add or subtract the numbers inside the surds, and how you kind of need to treat this, it's a bit like collecting like terms. So if you saw 2x plus 5x, then that would just simply equal 7x. The x's still remain the same, and likewise with regards to the surds. So when we're adding, subtracting, yes, you can join the numbers outside together if the square root numbers are the same. If they're different, there's nothing you can do about it. You can't join them up. Now the second thing kind of applies, which moves on to the next one, and the fact that if we had, let's say, 2 root 3 minus, let's go for 4 root 7, then because the numbers inside the square roots are different, there is nothing we can do to simplify this. So therefore that cannot be simplified, and it would just stay the same of 2 root 3 minus 4 root 7. And there we go. Now when it moves on to multiplying, so here, yes, we can multiply surds together. So if you are multiplying and you've got surds, we can multiply the numbers inside together. So if I had root 3 times root 5, then that would equal 3 times 5, which is root 15. And likewise, if you had numbers and letters, so for example here, when we're multiplying, if I had 2 root 3 multiplied by 7 root 2, then here I would multiply numbers outside together. Oh, don't want to do that, so let's get rid of that. So what I want to do is I can multiply numbers outside the surds together, which would give me 2 times 7, which is 14, and I can also multiply the numbers inside the square roots together, so that would be root 6, and there, so the final answer for this one would be 14 root 6. Now we then move on to dividing, and again, one of the rules of surds is just that with multiplying is, yes, you can multiply surds with surds, and you can also divide surds with surds. So here, if I had root 16, or root 14 rather, divided by root 2, then I could simplify this as root 14 divided by 2, which is therefore just root 7. And likewise, if I moved on to this one, so let's say I had, actually let's pick a different colour, let's go for blue. So if I had 20 root 3 divided by, let's say, 8, then here I can divide numbers outside with each other, but obviously the 3 remains protected, so there is nothing much I can do with that. So here I can do 20 divided by 8, which I can divide both numbers by 4. So then that would become a 5, that would become a 2. So my final answer would be 5 root 3 over 2. Now if you've got numbers with surds divided by another set of numbers with surds, then again we treat it separately. So here, for example, if I had, let's say, 24 let's go for root 10 over, let's say, 18 over root 2, then what I can do is I can split this up. So I can have the numbers outside being divided, so 24 divided by 18, and multiply that by root 10 being divided by root 2. So this becomes, well, I can divide both numbers by 6. So that would become a 4, that would become a 3. And I can do 10 divided by 2, which then becomes root 5. So giving me my final answer of 4 root 5 over 3, or I could write it as 4 over 3 root 5. And they're both the same thing, but I would say this one is probably a better way of writing it. So that's something that we need to can go into. So the next thing we move into is, okay, let's go have a look at some questions. Now again, as I've already mentioned, that when we're adding, subtracting, what you want to try and do is try and treat these questions like you're collecting like terms. So if the surds are the same, then they can be simplified. If they aren't, then they cannot be. However, if you have a large number being square rooted, always check to see if it can be simplified before performing any calculations. And again, if you're not sure what I mean by that, I'll go through an example. So let's have a look at some actual examples. So here we're going to simplify. Now, first thing I want to do is check, are the numbers inside the surds the same? Yes. So all I need to do is just add together the numbers outside. So here I've got 7 plus 5 plus 7, which leaves me with 12 root 2. So again, the root 2 stays the same. Now, again, how you want to treat this, as if I just pick a letter, treat it as 5x plus 7x, and that's if x was root 2. Moving on to question 2. So here I've got root 5s and I've got root 7. So what I'm going to do is I'm going to take these separately. So let's have a look at the root 5s first. So I've got 11 root 5 plus 4 root 5. So again, if I add those two things together, then that's going to give me 15 root 5. Then if I then look at the root 7s, well, I've got 3 root 7 plus 6 root 7. So that's going to leave me with 9 root 7. And that there is my final answer. Again, because I can't go any further, because here I've got root 5 and I've got root 7. And because they're different, there's not much else I can do. So moving on to question 3, here I've got root 2s and I've got root 3s. So here, looking at the root 2s, I've got 3 minus 8, which leaves me with minus 5 root 2. And then I've got 7 root 3 minus 7 root 3, which cancel each other out. So I'm just left with my final answer of minus 5 root 2. Now question 4, now when it talked about, obviously these square roots aren't the same, so there's nothing I can do in terms of adding. However, they are quite large numbers. Now when it comes to looking at this, what I need to do is see, can I simplify root 18? So is there a square number that is a factor of 18? And that is true. Yeah, there is. I can do 9 times root 2, and the square root of 9 is 3. So then I could rewrite root 18 as 3 root 2. Now also in terms of root 50, the biggest square number that goes into root 50 is root 25, and that's times root 2, so that could be simplified as 5 root 2. So here, when I've got root 18 plus root 50, then what I can do is I can swap those with these two things. So here I've got 3 root 2 plus 5 root 2, and now you can see that my surds are the same. So all I need to do is add the two numbers outside, which gives me a final answer of 8 root 2. Now moving on to question 5, so let's just get rid of all of this. So moving on to question 5, I need to look at the separate. So again, let me just split this up. So I've got 5 root 28, which is the same as 5 times, and again splitting up 28, asking myself, is there a square number that goes into 28? And there is, that's 4. So it's going to be root 4 times root 7. Now I can simplify root 4 as 2. So what it then becomes is 10 root 7. And then looking at 3 root 63, Well, again, I've got 3 times, and then if I look at what square number goes into both 63, well, that's going to be root 9 times root 7. I can simplify the root 9 into 3. So what that then becomes is 9 root 7. So what I'm now going to do is I'm now going to substitute 10 root 7 and 9 root 7 for these two calculations. So what I've got is 5 root 28 minus 3 root 63 can be written as 10 root 7 minus 9 root 7, which then 10 take away 9 leaves me with 1 root 7, or I could write it as just root 7, and there is my final answer. So let's have a look at multiplying. So with multiplying when it involves brackets, so when multiplying and dividing in fact involves surds, you must remember that you can only multiply numbers outside a surd with numbers outside a surd, and numbers inside a surd with numbers inside a surd. So looking at this now, when we're expanding brackets, I'm still going to use the method of loops. So here I've got 3 root 2 times 2. So here I've got a number without surd and a surd. So that's just going to leave me with 2 root 3. Subtracted by, now here I've got a surd times a surd, so I can multiply these numbers together, and that's going to give me root 9. Now simplifying that, there's nothing I can do with the 2 root 3, but I can simplify root 9, and that just leaves me with 3. Now from this, there's nothing I can do to simplify it, so that there is my final answer. So moving on to the next one, I've got root 5 times 5 root 25. So again, I've got a surd and a surd, so I can multiply them out. So I've got 5, and it's going to be root 25 minus, and then I've got 3 root 5. Now the root 25 I can simplify, so this then becomes 5 times 5 minus 3 root 5, which then leaves me with the final answer of 25 minus 3 root 5, and there is my final answer. So then moving on to the next set of questions. So again here I've got a number outside, a whole number there, and I've got the 4, so I can do 2 times 4, which is 8, and I've got root 11, minus, then here I've got 2 and then root 121. So again, how you want to treat this is, how would you, if I replaced root x with root 11 with x, then what this question would look like is this. So 4 times, you can only multiply numbers with numbers, letters with letters, and the same thing applies with numbers and surds. So here that would be 8x minus 2x squared, and the same thing kind of links in with these two things here, remembering that root 11 times root 11 is just root 121. Now, going back to this particular question, there's not much I can do with this, but I can simplify this. So that becomes 2 times, and then square root of 121 is 11. So that leaves me with the answer of 22. So what this then becomes is 8 root 11 minus 22. Now, when it moves to double brackets, again, we're going to use the method of whichever you use. So here we're going to do 8 times 8, which is 64. And then 8 times minus root 5 leaves me with 8 root 5. Then I've got root 5 times positive root 5 times 8, which leaves me with positive root 8 root 5. And then I've got root 5 multiplied by minus root 5, which leaves me with minus root 25. So here what I'm going to do is do a bit of simplifying. Well, 8 root 5 minus 8 root 5 plus 8 root 5 actually just disappears. They cancel each other out. So here I've got 64 minus, and then root 25 is 5, leaving me with a final answer of 59. And then doing the same sort of thing with the next one. So here I've got 5 times 4, which is 20, and then 5 times 2 root 3 is going to leave me with positive, and then 5 times 2 is 10, and I've got a root 3. And next I've got root 3 times 4, which leaves me with positive 4 root 3, and then 2 root 3 times root 3 leaves me with positive 2, and then root 9. So simplifying this, I've got, well, 2 root 9 is going to be the same as 2 times 3, which is 6. So from this I've got 20 plus, now if I join these two things together, as you can see the surds are the same, So I've got 10 root 3 plus 4 root 3 leaves me with 14 root 3. And here I've got 6. And that leaves me with a final answer of 26 plus 14 root 3. And there is my final answer. So moving on to the next set of questions. So here, again, using my loops, I've got root 3 times 9 root 3, which is 9 root 9. And then root 3 times 5 is plus 5 root 3. Then I've got minus 1 times 9 root 3, which is minus 9 root 3. Again, 1 times 9 is 9. And then minus 1 times 5, which is minus 5. So from this, I could then simplify this as 9 times 3, which is 27. So that's going to be 27. And then 5 root 3 take away 9 root 3 is minus 4 root 3, minus 5. Now from this, I can join these two things together, giving me a final answer of 22 minus 4 root 3. And then moving on to the penultimate question. So here I've got 4 times 3, which is 12, and I've got root 3 times root 3, which is root 9. And then I've got 4 root 3 times 4 root 2. So again, 4 times 4 is 16, and I've got root 3 times root 2, which is root 6. Then moving on to the next set, I've got minus root 2 times 3 root 3, so that's going to give me minus 3 root 6. And then I've got minus root 2 multiplied by minus 4 root 2. So two minuses become a plus. It's going to give me 4, and then root 2 times root 2, which is 4. So got a lot of simplifying here. So this becomes 12 times 3, which is 36, minus 16 take away 3 is minus 19 root 6. And 4 root 4 is 4 times 2, which is 8. So that's going to be plus 8. So joining these two things together, what I end up with is 44 minus 19 root 6. And there is my final answer. Now when it moves on to this last one, let me just move up the screen. So here I've got 3 minus root 5 squared. Now the key thing to remember that this is not equal to 3 squared minus root 5 squared. The key thing you need to remember, and this is where these questions are very, very popular, is recognizing that this means 3 minus root 5 multiplied by 3 minus root 5. So expanding the brackets, I've got 3 times 3, which is 9. And then 3 times minus root 5 is minus 3 root 5. Then I've got minus root 5 times 3, which is minus 3 root 5. And then I've got minus times a minus is a plus, and root 5 times root 5 is 25. So simplifying this, I've got 9 minus, well, minus 3 minus 3 is minus 6 root 5, and root 25 is just 5. So simplifying these two numbers at the end, I've got 9 plus 5, which is 14, minus 6 root 5, and there is my final answer. So I will leave some questions along with their answers in the description below for you to practice everything we've covered in this video.